384,400 kilometers away from us. But if I asked you to guess it, would you guess that exact same number? 500,000, a million kilometers, does it make any difference? The thing is, our brains never had to think about things farther than the horizon, nor to visualize more items than the amount of berries that could fit in our palms. But if we use familiar items which size we understand, we could start to understand the real proportions of the universe. We'll start with the solar system. I'm not much of a sports type, but I've seen this thing on TV. People fight to get it, trying to throw it through a loop. Hilarious. It's 24 centimeters in diameter and it will serve as our sun. And with my sun, I made this set of clay planets, which are made proportionally smaller to our sun. I will arrange them along the road as we keep getting farther away from the sun. Let's place this ball here. We have our sun here at the foothill of this tall building. If you ever saw an illustration of a solar system in one of those books, or any encyclopedia, you've seen that planets are huge and clumped together around the sun. Because that's the only way to illustrate all that on one page. Or you've seen those YouTube videos where small planets are next to the big ones, and it gets bigger and bigger up to stars, and you see how bigger they are one next to another, but you don't see all the empty space between them. The problem with this type of representation is that you have to pick the right scale. If I picked a bigger ball, like a beach ball, we would have to go too far to find Neptune. We would lose our sense of scale. If I took a tennis ball, Mercury would be microscopic and we would lose sense of scale again. This ball is perfect. Let's see where Mercury is. Mercury is a grain smaller than millimeter on the tip of my finger. And at these proportions, it's 10 meters away from the sun. From our ball, right here. I'll put this red flag so we can find it later. It's nothing like in the books, right? Look at all that empty space between the grain smaller than a millimeter and that basketball all the way there. The next planet is Venus that I colored yellow with this yellow flag. It's at 18 meters from our sun, right about here. Earth is next little grain 2 millimeters wide, blue in color, and it's 25 meters away from our basketball. Right here underneath this tree. This distance, I'll put it right here. Do you see this distance between us and the basketball all the way there? That distance is called astronomical unit, distance from Earth to Sun. And light takes 8 minutes traveling at 300,000 kilometers per second to get from the sun to us. Astronomical unit is important as it shortens the units we need to measure our solar system. Mars is next. In this model it's a bit over millimeter wide, red in color. And it's 1.5 astronomical units away from the sun. In our model it's 39 meters away from the basketball at the foothill of that tall building. And it's somewhere around here. Now we have big players. Jupiter, which I have here, is not really in the correct proportion, but it's supposed to be around 2.5 centimeters in diameter. It's at 134 meters away from the sun, and in real space it's about 5.2 astronomical units. That's 5 times the distance between Earth and the sun. Jupiter. Saturn, slightly smaller than Jupiter. In our model it's about 246 meters from the basketball near that building. And in real proportions it's 9 astronomical units. Uranus is at 494 meters from the basketball near that building at a distance. That's 19 astronomical units. Neptune is at 30 astronomical units, which is 775 meters from our basketball. Imagine all that emptiness. 18 millimeters wide Neptune here and 24 centimeters wide basketball at the foothill of that building all the way there. And absolutely nothing in between, other than these planets I just listed. That's the proportion we will need later. Try to keep the mental image of this distance. After Neptune, we have Pluto about a kilometer from the ball near that building, and a whole bunch of dwarf planets, but we won't be bothering with them as we're just beginning to understand the scale of the whole universe. So now we know how big it all is, how big our solar system is. Now it's time to look at our neighborhood. All the stars which, along with our Sun, circle in this huge vortex of stars called the Milky Way Galaxy. There are 250 billion stars in there. How much is that? Just very, very much. But I know a perfect way to illustrate just how much that is. Come with me. The real estimates vary between 250 to 400 billion. We'll stick to the smaller estimate. You guessed right. I'll use grains of sand to illustrate just how many stars there are in our galaxy. Each grain of sand on this beach will be one star in our galaxy. I don't know how deep this sand goes, so I'll take just the sand that we can see on the surface. From us to the river shore there is about 50 meters. This bridge will be our starting point. Keeping in mind all the sand that you can see on the surface here, and you saw how fine it was in my hands. 50 meters across, and I'm heading that way, and we'll see how far I have to go until 250 billion stars pass on my right. Let's go. And here I am, 200 meters from that bridge, 50 meters from that shore. All this sand that we can see is the number of stars in our galaxy. Some of them have planets orbiting them. Some of them have additional stars spinning together with additional planets orbiting each. Imagine all those planets for us to explore. But in order to make this simulation perfect, we have to remember they're not packed this tight. They're widely spaced. That's interstellar space. Our first interstellar neighbor is Proxima Centauri, part of Alpha Centauri system a bit over 4 light-years away from us. In these proportions, where our basketball is left near that building and Neptune is where I last left it, Proxima Centauri is somewhere in Boston. Some 600 and 900 kilometers from here is our first interstellar neighbor. We know there are planets orbiting it, and we would much like to visit them. But before you embark on a starship and think you can reach it within your lifetime, let's put these things in perspective. Take this coin. Let's say Sun is in its center, while Neptune orbits at its outer edge. I'll leave it here on the floor, and we'll see how far I'll have to walk until we get to Alpha Centauri system. I'm heading away from our coin, and now we're in interstellar space. Along the way we'll encounter a few atoms of hydrogen or a random speck of dust. Alpha Centauri system at 114 meters from that building where we left our solar system. Here it is. 4.4 light-years. And between us? Vacuum. Absolute nothingness. Try and reach Alpha Centauri without refueling, without resupply. In one go. Sounds like an amazing endeavor. So we saw the size of our galaxy. But I said our galaxy. That means there are other galaxies. There's actually so many that I would have to go to the beach again and use sand grains to illustrate how many there are. Andromeda Galaxy is our first intergalactic neighbor. It's 2.5 million light-years away, and it's spiral in shape, just like Milky Way. But to finish off, how far are galaxies one from another? If this coin is our galaxy, the Milky Way, which is 100,000 light-years across, where will Andromeda be? I'll put this coin right here. You thought I will walk again, didn't you? The thing is, galaxies are not spread so widely as stars are. Actually, Andromeda is huge in our night sky, much bigger than the moon. We just can't see it as our eyes can't see such dim objects. Its light fades before it reaches us. Even though we can only claim things for observable universe, A study from 1999 suggests that there are 125 billion galaxies. Another study from 2013 suggests 250 billion, just like number of sand grains we saw on the beach. Each of these galaxies contains billions of stars, each star potentially with planets. Study from 2016 suggests there are 2 trillion. No one really knows, and due to light speed limitations we might never know the exact number. These things play weird tricks with our minds. How do we feel about everything knowing we're on this small blue ball in the middle of nothingness? We can feel completely meaningless, but to the other hand we can marvel at the universe and being a part of such a large thing. Carl Sagan said, "We are the way for the universe to know itself. Without us admiring it, it would be nothing but a lot of empty matter and energy." I hope this video made it possible for you to perceive the true size of the universe and showed you your place in it. If you like this type of videos about science, technology, sci-fi and futurism, subscribe to our channel and think about supporting us using the link in the video description. See you next time, but until then, take a look at the night sky from time to time and admire its beauty and sheer size. Bye.